All right. Example 6 looks a lot like the previous examples, but there's a good reason I'm showing this to you. Because when, if they give you a system of equations that has one variable to solve for, then doing anything but solving for that and working back is kind of a waste of time. And it says to solve by Gaussian elimination. I don't see the point when it's going to be a whole lot more work to do that than to just do this. And then continuing up, x plus y minus z. Okay, y is -8, z is 2. Looks like we get x minus 10 equals -1. And we're done. So Gaussian elimination is interesting, and it kind of gets rid of the variables, but it also shouldn't be used just because we're asked to. Okay, I mostly want to just show you how these problems get set up. So we got this situation with both copying machines A and B are working. Secretaries can make 120 copies in 1 minute. In 1 minute's time, copiers A and C together produce 90 copies. All three working together produce 170 copies. So we're going to assume that's A, B, and C. And A and B, 120. All right, I got that wrong. No, I didn't get it wrong. I just skipped the very first fact. Okay, A and C work together. It's A and B makes 120. Okay, so this goes into a Gaussian matrix. 1A plus 1B plus 0C equals 120. Uh, 1A, 0B, 1C equals 90. And 1, 1, 1 equals 170. So I'm just showing you how to set this up. When you solve it, as like on the quiz, you'll get all kind of really nice even numbers. So do your Gaussian elimination on that and solve the system. Okay, I didn't need all that room because I decided not to do that problem. I trying to save time here. Okay, I want to show you how this works. It's really actually a very simple problem, but you have to make some assumptions. So it says the speed of an airplane with a tailwind is 320 miles per hour. And the speed of the airplane with a headwind is 250 miles per hour. So what you have to, the assumption you have to make, now we're going to call the speed S, and we're going to call the tailwind W. So it adds to your speed if you're getting pushed from behind. Now here's the big fat assumption, that the headwind is the exact same speed as the tailwind. So you've got these two equations. Easiest thing to do with them is to just eliminate the W's by combining them. And then solve for S. So it gives the airplane speed as half of 570, which looks like 285 miles an hour. and they ask how long will it travel in a 6-hour fuel supply. So 285 miles per hour times 6 hours. Just doing a little dimensional analysis here. I get miles. Do my multiplication, 1,710 miles. Okay, last thing I'm gonna pause the video and go to the quiz site because I want to show you how to set up one of the problems. I'm not going to do it, but setting it up is tricky. Okay, so this is one of the quizzes, and all I'm going to do is set up the matrix, and then you can go ahead and solve it. So they say 1 ounce of each of 3 foods is the vitamin mineral content shown in the table. How many ounces of each must be used to provide exactly 16 milligrams of niacin, 15 milligrams of zinc, and 15 milligrams of vitamin C? These match perfectly with the columns. So food A, B, and C. So what we do is for the niacin, okay, in A, there's 1 ounce in food A. So we have 1 times A, and there's 2 ounces of niacin in B plus 2B, and then 1 ounce of niacin in C plus 1C equals the total amount of niacin. Okay, now I usually wouldn't write the ones, but I wanted to make sure you knew where they were coming from. So to finish setting up this matrix, A plus B plus 2 equals 15. So I used these numbers, and then that total amount of zinc they gave us. And lastly, we'll do that for vitamin C. A plus B should be a 2C. And then A plus B plus 2C, they have equal to also 15. All right, well, that's how you set it up. The matrix, if you choose to solve it with a matrix, 1, 2, 1, 16. So solve that. I'm kind of taking my time because I think it's interesting that the zinc and the vitamin C have exactly the same. But let me know if you're running into any trouble. All right, that's it for this chapter. I'll see you in class.